I want to look at adding and subtracting in algebra now, but again, I just want to revise the general concept first. If I am adding a lot of numbers or adding and subtracting together because they're the same thing, they're just one goes up and one goes down. I actually I can do it in the order that it's written in. I can always do that. So I can go 2 plus 3 is 5, minus 4 is 1, plus 1 is 2, minus 2, and back to 0. Okay, so the answer to this problem is 0 if I just work my way along. And I can always just work my way along from front to back when I'm on the same level in terms of order of operations. And plussing and minusing are in the same level, same way timesing and dividing are. And powers, squaring and square rooting. So if it's all the same level, I can do that. But I can also rearrange it if I want to, as long as I remember that that minus belongs to the 4 and that minus belongs to the 2. So a plus and a minus sign belong to the thing that come directly after them. It's sort of like a title, like Mr. or Mrs. You never say Jones Mr. You always say Mr. Jones. So I can actually go 2 plus 3 is 5 plus 1 is 6, and then I could minus my 4 and minus my 2 and still get down to 0. Or I can go 2 minus 4 is neg 2, plus 3 is 1, plus 1 is 2, minus 2. It really doesn't matter what order I do this in as long as I do each thing once and I carry the minuses with those pieces. So that's the first thing I want you to remember when we're looking at adding and subtracting in algebra. With algebra, we've got to consider that we've got unknown letters. So I've got this problem here. When I've got pluses and minuses as my main sign between things, I no longer want to look at rabbits. I no longer want to look at fish. I want to look at this problem now like we're at a marketplace. Now, when we're at the marketplace, the letter represents the fruit and the number represents how many of that fruit. So say M is for mangoes. I have 7 mangoes. I got another 6 mangoes. And then I lost 2 mangoes. So I can go 7 and 6 is 13 minus 2 is 11. Or I could have gone 7 minus 2 is 5 plus 6, still 11. In the end, I have 11 mangoes. The reason I also want to talk about mangoes and fruit is that while we're adding and subtracting, all we are doing is counting those mangoes. I didn't change this to a mango squared or a mango cubed. That's because I wasn't making bunny rabbit babies. There was no reason to change that power. I didn't get any extra m's timesing together. I literally counted 7 and 6 and lost 2 of the m. Now, this one's maybe a little bit too fancy for the next one, but hey, we'll just stretch a little bit. Now I have apple bananas. I don't have albino black bunnies. I have apple bananas. I have 2 apple bananas. I have 3 chocolate bananas. And I have 2 more apple bananas, but as a loss. So in this one, if I gain 2 apple bananas, I gain 3 chocolate bananas, but then I lose 2 apple bananas, I actually only have my banana chocolate. Now notice I called it chocolate banana or banana chocolate. That's another really important concept. 3BC is exactly the same as 3CB. I can read it either way. I can group it either way. If I have one lot of banana and one lot of chocolate combined, then that's all I've got. I always like to write it alphabetical order. In fact, we all do. That's sort of an algebra convention so that they're easier to spot when they're the same. So we don't write it like this. This one, however, is not the same as that one. And that's because that squared belongs to the B, whereas that squared belongs to the C. And if you think down to the bunny rabbits, this one's going to have different genetics to that one. No, I've just mixed bunny rabbits and fruit. But you've got to understand that whenever I do these stories, they are only standalone in a moment of what am I doing right now. But you should still be able to look at each piece and relate them back. If it's just an individual bit, like this bit here is we've done a bunny rabbits to get that, and we've done a bunny rabbits to get that, and you would be able to tell me straight up that even though they've got the same quantity, those bunny rabbits are not the same. So Here I've got 2 apples. I then get 3 bananas. I then then I gain 3 apples. So that means I've got 5 apples altogether, but I lose a banana. That's all we have to do. Apples and bananas. Make sure they match exactly. Over here I have crates of xylophones. I have no idea. This is a really random market. I have a crate of 5 crates of xylophones, 4 straight xylophones, 3 more crates of xylophones, and 7 straight xylophones. Now, this seems weird that we can't group these together, but remember, like, if you actually had 1,000 of something and then you had 25 of something, you have to say 1,025. You can't actually break that down any other way and combine the 25 into the 1,000 that you've already grouped. So these big crates you could think of being like thousands. They are the same thing but larger. So when we're grouping, we actually, if they're a different place value, we've got to group them differently. So we group the 5 with the -3, and we end up with 2 crates of apples. Doesn't change, it's still crates. We lose apples, xylophones. We lose 4 xylophones, but then we gain 7, so a net gain of 3 straight xylophones. What we've got to do is we've just got to look along the line and go, okay, this one and this one match. Mango nuts? Who knows? Whatever, make it up. So they can group together with 6 and 3 is 9. Still just mango nuts. And the crates of mangoes have to hang separate. That's all we're really doing.